Welcome back for part 4 in our 5-part series on AI. In part 3, we were talking about machine learning and the somewhat recent change to deep learning, where we build a model by taking lots of examples that have been labeled as perhaps car or not car, and then being able to give it a new picture and have it decide based on the model, is it a car or is it not? Generative AI is taking that same model, but flipping it around. Instead of saying, here's a picture, use the models to tell me whether it's a car or not, we're now saying, I want to use this model to create a picture of a car or whatever. If we've learned a model that can tell us, yes, this is an example of something, we can use that same model to say, create an example of that same kind of concept from scratch. So the most well-known examples of generative AI involve large language models. That is a model, in the same sense that we've been talking about models for the whole machine learning time, about language. That is, the model is trained by looking at documents written in, we'll say English, but any language. And it is large because it is based on a huge amount of text. I can't show you anything meaningful with a large language model because, well, they're large. But I have a very small language model here. This is based on the way that my 3-year-old at the time talked last winter. She was somewhat speech delayed and didn't say very much. About 30% of the time, if she said something, it was the word mama. About 20% of the time, if she said something, it was dada. Another 20% up. 20% of the time, she said the phrase throw snowball. And 10% of the time, she said the phrase pee potty. Just based on that information alone, I could come up with a computer program that tries to simulate sounding like my daughter as a 3-year-old. 30% of the time, it would say mama. 20% of the time, it would say dada. 20% of the time, it would say up. And if somebody handed me a bunch of pieces of paper with, here are things your daughter wrote, and here are things that the computer program wrote, I probably wouldn't be able to tell them apart. But a language model can be much more complicated than that. For example, my daughter frequently repeats things that are said to her, even if they're not part of her normal vocabulary. So part of our language model could be, if you say truck, she will probably say truck. Also, she frequently repeats herself. So part of my large language model is, every time that we hear mama, we then say mama, mama. Or not every time, but often enough. We can even put in sophisticated rules like, we don't say pee potty at random intervals. We say it approximately every 3 hours because that's approximately how often we observe her saying it, because that's when she needs to go to the bathroom. So based on that more complicated language model, I could really make something that could intelligently, sort of, sound like my daughter. Large language models include all that kind of information and much more. So not just how frequently does each word occur, how often do 2 words come after each other, how often do certain kind of words get used in certain kinds of documents, how certain words are similar to other words because they're used in similar ways, how often words appear near to each other in documents, understanding that this is a verb and this is a noun, and sentences have a noun phrase and then a verb phrase and then perhaps an indirect object, etc. We can just provide a dictionary that says, here's the definition of this word, a thesaurus that says, here's 7 other words that mean approximately the same thing as this word, and we can provide some domain-specific knowledge. Like if we want to train a large language model that's going to be building recipes, we'll give it information about how different chemicals react when they are cooked in different ways. And using this, we can build very, very, very complex language models that can do a very, very good job of simulating a person talking who's much more sophisticated than my 3-year-old daughter was. If you'd like to experiment with these, the most well-known one by far is ChatGPT, made by a company called OpenAI. Google has their own product called Gemini. Microsoft has a product called Copilot, which at this point is embedded directly into the most recent versions of their tools like Microsoft Word and PowerPoint. So if you use those, you may be having an opportunity to use generative AI directly in your work as a way to help you. In addition to these very well-known ones for generating text and many other ones, There are also a bunch for generating images. DALL-E, also from the company AI, Midjourney from the company that named the product after themselves, Stable Diffusion, and some others. So both of these have the idea of, I was given a whole bunch of examples. For the top examples, they were documents written in text. For the bottom examples, they were labeled images. And I trained a model, and now I'm going to use that model not to classify things, but to produce either new documents or new images in a class. That's incredibly powerful. If you haven't experimented with ChatGPT or any of these other tools yet, you definitely should. I'll just give you a brief demonstration right now. So ChatGPT is available for free over the web, at least for now. There's an area down here for me to type in a prompt, and that is a message telling the system, hey, I would like you to generate a document, based on this text. So one way I might use ChatGPT is I might ask it questions that I want to get answers to. So for example, who won the women's discus throw in the 2024 Summer Olympics, which I spelled wrong, but told me the winner of the women's discus throw at the 2024 Summer Olympics was Valerie Allman from the United States, etc. Is that true? Perhaps I should have looked it up before starting this video. I'm going to assume that it is. I can also ask it questions that do not have such an obvious, simple, factual answer, like a question that's been bothering me and my family recently. Why are there centipedes in my basement? And it'll write me a much longer, more in-depth explanation of that. Tells me they like dark, damp environments, basements have moisture and darkness and food sources and shelter, and it even tells me some things I could do to try to get rid of them. Okay, another way I can use ChatGPT is to sort of generate ideas for me. Like I might say, give me 10 ideas for games to play at a 4-year-old's birthday party. And it'll give me 10 games. Duck, Duck, Goose, Musical Chairs, Simon Says, Pin the Tail on the Donkey, Treasure Hunt, etc., etc. If I like some of those, I can use them. If I like all of them, I can use them. If I hate all of them, I could say, I don't like those. Could you give me 10 more? And it'll give me 10 more. So that's a very useful tool if you're trying to decide on some things to do. ChatGPT can brainstorm for you. It can even write complex documents. Like, let's say, write an essay arguing that alien life probably exists. And here we have such an essay. Lots of paragraphs. You can see each one appears to be written in great grammar. It makes sense. It's written like an essay that a student might write. I can also say, okay, now write me a rebuttal to that essay. And it'll tell me why all of that was wrong, and I should think the other way instead. I might say, okay, but make it much shorter. And it'll make it somewhat shorter anyway. So as you can see, ChatGPT seems to know a lot. I'm able to ask it questions and get answers that at least seem to be correct. Furthermore, it's not just knowledge about the world that it has, it seems to understand how to put sentences together. I can read the sentences here and they actually make sense. Something like, current detection methods, such as those used by SETI, may not be effective for identifying alien life if it uses communication methods vastly different from our own. That's a good sentence. It also is relevant to the query I gave it. So It seems to understand the domain of the knowledge I'm asking for. But does it really? It's an interesting question. What I'm doing here, or what's going on behind the scenes, is just a vastly more complicated version of that small language model I gave for my daughter. Does it understand English? Does it understand what's going on with centipedes, or what games might make sense to play, or whether alien life exists? I don't know. Does the man in the Chinese room understand Chinese? Because this seems like a very analogous situation. So I think it's a very open question whether philosophically we should say that our system understands English or understands any of the questions I asked it. In a sense, this incredibly complicated model represents some kind of understanding. In another sense, it just knows that these words go together in a way that will make people happy. And I don't know if we saw any examples of this or not, but systems like this are known to hallucinate. That is, simply make up facts in citations when they don't know the real ones. So maybe the winner of the discus throwing competition was somebody else. I don't know. I'll have to go check later. So what does all this mean for us as a society? That's what we'll talk about in our final part 5.